All right, Trig lecture 1020, 1021. The student will solve trigonometric equations just like we did in the last lecture, in the last couple of days. We're going to solve trigonometric equations. We're going to limit values of theta to between 0 degrees and 360 degrees. That says 36, you should say 360. Fix that. There we go. The student will appeal to special case triangles. We've already talked about those. The unit circle, we've talked about that. And all students take calculus. These are the places, the places where each of the trig functions is positive in the coordinate plane. That's what that refers to, as we've talked about. We're going to do the exact same thing we've done, except our trigonometric equations are going to be a little more complex. You can solve these using your calculator. I'm going to do old school combination of calculator and what's left of my brain. Now here we go. I want to isolate sine theta. So here's my plan. I'm going to add 3 to both sides and then divide both sides by -1/2. In other words, I'm going to invert and multiply. To add 3 here, I'm just going to say plus 3. When I add 3 here, I'm going to have a common denominator of 4. So I'm going to call it 12 over 4. 12 over 4 is 3. You can just say plus 3, put this in your calculator, and say plus 3, and it will do all the arithmetic for you. I'm just going to do it old school. This will yield -1/2 sine theta is equal to, I have common denominator, so I'm going to add my numerators. This will be -12 plus 12 is 0. So I'm left with radical 2 over 4. You leave the denominator the same and add the numerators. If I add these 3 numbers, 12 cancel out, and use radical 2 over 4. Now I want to divide by -1/2. To divide by -1/2, I'm going to invert and multiply. I'm going to multiply both sides by -2 over 1. Multiply this side by -2 over 1. And again, you can do this with your calculator. I'm just doing it old school just because I'm old school. These will cancel out. Negative times negative is positive. That's 2 over 2. 2 over 2 is 1. 1 times sine theta is sine theta. Equals whatever this simplifies to. It's going to be negative because one of them is negative. 2 over 4 will reduce to 1 over 2. So that's a 1. That's a 2. That leaves me with 1 times radical 2 is radical 2. 2 times 1 is 2, radical 2 over 2. Now we do what we did in the last lecture. This is not a 0, a 1, or a -1, so I'm going to appeal to a special case triangle. A special case triangle that involves -2, that involves a radical 2 and a 2 is the 30-60 right triangle. Whoops. See if I can draw or write correctly. 30, 60, right, 1, 2, radical 3. I said 30, 60 right, and it's actually 45, 45 right. Sorry about that. 1, 1, radical 2. So it won't be the 30, 60 right, if for some reason my brain is damaged and that popped into my head and it was the wrong one. This is the one we'll be appealing to. As soon as I saw it didn't have a radical 2 in it, I knew I was wrong. So I went to the other one. Now, sine of what angle is radical 2 over 2? Well, the sine of this angle is 1 over radical 2. Sine of 45 degrees, at opposite over hypotenuse. If you put this in your calculator will rationalize the denominator, and it will tell you radical 2 over 2. That's what it'll do. It'll multiply the top and bottom of this by radical 2. You get radical 2 times 1 is radical 2. That's 2. Square root of 2 times square root of 2 is 2. So, as I was saying, you could use your calculator to do this. You don't have to do it old school. But my reference angle is 45 degrees, and that's the important thing. Reference angle, 45 degrees. And so now I want to know where is the sine negative. Draw a couple of reference angles of 45 degrees there and then determine that rotation. So here we go. The sine is negative, not here. The sign, all students, that sign, that's where the sign is positive, so it's not negative here. It'll be negative in quadrant 3 and negative in quadrant 4. Everything's positive in quadrant 1. The sign is positive in quadrant 2, so we're looking for where it's negative. It has to be negative in these two. My reference angle is 45 degrees. So in quadrant 3, my reference angle would look like this. There's my reference angle. I want to know what is this rotation. That would be 180 plus 45 is 225 degrees. Theta is 225 degrees. Or I could be in quadrant 4. Get that out of our way. If we have a reference angle, quadrant 4, that's between the terminal side, that's a horrible angle. And the nearest x-axis, if this was my reference angle, we're looking for this angle of rotation, which would be 270 plus 45, which would be 315. Is that right? Let me do that with my calculator. Yep, yay. That'd be a rotation of 315 degrees. And that would be the other place where the sine of theta would equal negative radical 2 over 2. And let's see if I got that right. Can't find my enter key. And that's just the way the day is going. Ah, here it is. First one, 225 and 315, 225, 315. The second one, I haven't done yet. Yay, 225 and 315. I'm on a roll, one in a row. So let's take a look at this one real quick. We're doing the exact same thing we did the last couple of days, except we've got to simplify this first. And then we do exactly what we did for the last couple of days. So what I'm going to do is solve this by subtracting 2 from both sides, and then dividing both sides by negative 1/5. To divide by negative 1/5, we invert and multiply, which will be the same thing as multiplying by negative 5. Subtracting negative 2 yields negative 1/5 cosine theta is equal to 0. And that's negative 1/5. Now I want to get rid of a multiplied negative 1/5, so I'm going to invert and multiply, flip it over, 5 over 1, and multiply. And we'll get, this turns into a fancy 1. Negative times negative is positive. It leaves me with 1 times cosine theta. And this turns into, I don't care what you multiply by 0, it turns into 0. So I'm looking for where cosine is 0. That means I'm going to use the unit circle. If it's 0, 1, or negative 1, it's going to be the unit circle unless our function is tangent. So here we go. This point has coordinates 1, 0. That's an x coordinate and a y coordinate, and the radius is 1. This point has coordinates over 0, up 1, and the radius is 1. This distance from the center to the point of intersection. Similarly, this would be negative 1, up 0, radius is 1, and over 0, down 1. This is x, y, the radius is 1, x, y, this would be x, y. And that would be x and y. Yay, there's our unit circle. I should have drawn that in advance. I want to know where is, let's see what cosine is. X is horizontal, y is vertical. We put theta right here. R is the hypotenuse. Cosine is adjacent over hypotenuse. Cosine of theta, I'm looking for x over r. So I'm going to go around looking for places where x over r is 0. Is x over r 0 here? 1 over 1? No. Now remember, the initial side is the positive x-axis, and we're rotating. If we don't rotate at all, 0 degrees isn't one of our answers. If we rotate to 90 degrees, we test to see if x over r is equal to 0. X over r is equal to 0, so 90 is one of my choices. How about x over r if we rotate to 180 degrees? That's our angle of rotation. X over r would not be 0. We're looking for where it's 0. So 180 is straight out. You can't take that into consideration. But what if we rotate to 270 degrees? Here's our angle of rotation. X over r is 0 over 1, so that's 0. So theta could be 270 degrees. And we would stop there. We wouldn't rotate back to 360 because we're limited by our instructions. 0 is included, 360 is not. We're only going one trip around and we're not quite reaching 360 degrees. So there we go. Those are our two solutions unless I've made a mistake. And let's see. Looking at the wrong answer sheet. 90 and 270 degrees. Yay! I left off my degree symbol. All right, let's take a look at the last one here. I'm going to isolate tangent theta by just adding 4 to both sides. When I add 4 to this side, I'm going to have a common denominator of 3. And this will be 12 over 3. That makes it 4. I added 4 here. This is 4. So I call it 12 thirds. You can just do this with your calculator if you want. We get tangent of theta is equal to, I'll add my numerators and leave my denominator the same. That would be 0. 12 plus negative 12 is 0. Radical 3 over 3. And that tells me that I have probably made a mistake. Let me see if that is actually, I'm looking at the wrong one. Did I copy that down incorrectly? No, I copied it correctly. Adding 4. 1, 2, radical 3. Oh yeah, that would be 6. My brain is damaged. I was thinking radical 2 again. 1, 2, radical 3. I'm an old man. That's just pitiful. 30, 60. Right, this is the one that involves the radical 3. I was visualizing the 45, 45 right. For some reason, my brain jumped to that. So now, I'm looking for the angle which has a tangent that will yield radical 3 over 3. So let's try the tangent of this. This is radical 3 over 1. That won't work. Let's try the tangent of 30. The tangent of 30 degrees is 1 over radical 3. If you put this into your calculator, whenever you see a radical in your denominator, go ahead and enter it into your calculator, and your calculator will rationalize that denominator, like we did years ago in Algebra 2. Call it radical 3 over 3. And so our reference angle here is a 30-degree angle. Reference angle, 30 degrees. And it's going to be positive. So I'm going to look to see where tangent is positive. All students take calculus. So it could happen in quadrant 1. That's where tangent is positive because everything's positive here. It can't happen in quadrant 2 because the only thing that's positive is sine and it's reciprocal. It could happen in quadrant 3. The angle could be in quadrant 3 because that's where tangent. It cannot be in quadrant 4. Our initial side is the positive positive x-axis. If I rotate to a reference angle of 30 degrees in quadrant 3, I'm at 180 plus 30 is 210 degrees. Just like we did last couple, and that would be a value of theta. And in quadrant 1, that's our other one, and our reference angle is 30 degrees. This angle of rotation would just be 30 degrees. So that would be another value. Those are our two angles such that if I take the tangent of them, I'll get radical 3 over 3. Get 1 over radical 3, which is represented with a rational denominator, radical 3 over 3. Do it with your calculator, you'll see. Let's see if I got it right. Wrong one again. I keep looking at the wrong one. 30 degrees, 210 degrees, 30 degrees, 210 degrees. So there we go. Very similar to what we've done for the last couple of days. The only difference being is that we have got to simplify our equation first. We solve it for the sine of theta. Once we do that, then we use the same thing we did for the last couple of days. It's negative. We determine what quadrants we'll have to be in, and we determine the reference angle, draw the reference angle in those two quadrants where sine is negative, and state the angle of rotation. You can do this.